Have you ever been told to maybe cut back on red meat and eggs because they're, bad for your heart? For years, that's been the standard advice. But what if that story, the one we've all heard, is missing a massive piece of the puzzle? Well, today, we're diving into a groundbreaking 2025 study from Nature Metabolism that is completely rewriting the rulebook on diet, our gut bacteria, and our health. Let's get right in.
Right. For years, it's been drilled into us. The headlines, the health warnings, all pointing the finger at red meat and eggs as a one-way ticket to heart disease. And the supposed villain? A nutrient they contain called choline. The story was simple and honestly pretty scary. Eat these foods and your body starts a chain reaction that could harm your heart. But as we were about to find out, that is not the whole story. Not even close.
So here's how the old story went. Step 1, you eat something with choline. Step 2, your gut bacteria get to work and turn that choline into a gas called trimethylamine, or TMA for short. Then your liver takes that gas and converts it into something called TMAO. And for more than a decade, TMAO has been public enemy number 1, linked again and again to a higher risk of heart disease. It seemed like a simple, straight line from your plate to a major health problem, or so we thought. But what if we were so focused on the end of the story that we missed a key character at the beginning? What if we've been blaming the wrong molecule this whole time? Because this new research has just dropped a stunning plot twist that turns everything we thought we knew completely on its head.
So welcome to part 1, the Choline Paradox, a story where a supposed villain is about to be unmasked as a totally unexpected metabolic hero. Okay, this is the absolute heart of the matter. We have got to separate two very different players, TMA and TMAO. The best way to think about it is this. TMA is the gas made by your gut bacteria. TMAO is the exhaust that comes out of your liver after it processes that gas. And that one little distinction changes, well, everything. Because while the exhaust, TMAO, is linked to heart issues, the gas itself, the precursor, TMA, turns out to be incredibly protective for our metabolism. How can the precursor be good when the end product is potentially bad? That is the paradox we're here to solve.
And hey, don't just take my word for it, here's a direct quote from the paper. The researchers say that TMA, unlike TMAO, actually improves how your body handles blood sugar and calms down your immune system, especially when you're eating a high-fat diet. So the very first step in this supposedly dangerous pathway is actually protective. The big question is, how on earth is it doing that?
All right, part 2. We're going under the hood to see how this simple gas, made by bacteria, can literally hijack our own cellular machinery for our benefit. First, we need to understand the problem TMA is solving. It's something called metabolic endotoxemia. Now that sounds complicated, but the idea is simple. A typical high-fat Western diet creates this constant, low-level buzz of inflammation all through your body. And it's this chronic inflammation that is a huge driver of insulin resistance, which is basically the first step on the road to type 2 diabetes. Now, this inflammation doesn't just happen randomly. It follows a very specific chain of command, like dominoes falling. It starts when a high-fat diet flips a switch on our cells called Toll-Like Receptor 4. That signal then gets passed to a crucial master switch, a protein called IRAK4. Once IRAK4 gets the signal, it unleashes a whole cascade of inflammation, which leads directly to insulin resistance. The key player here, the one you need to remember, is IRAK4. If you could control IRAK4, you could stop the whole process dead in its tracks.
So the researchers went on a hunt. They wanted to know how TMA was working its magic. They screened it against 456 different human kinases. Those are all the different switches that run our cells. And out of all those possibilities, they got a direct, specific, undeniable hit. TMA physically sticks right to IRAK4, that inflammation master switch.
And this is where it gets really mind-blowing. TMA isn't just some random byproduct of digestion. It's acting like a sophisticated, precision-guided drug called a kinase inhibitor. Our own gut bacteria are literally manufacturing a compound that works just like a targeted pharmaceutical to shut down a key inflammatory process in our own cells. And we're not just talking theory here, the numbers back it up. The amount of TMA needed to shut down half of IRAK4's activity is tiny, just 3.4 micromolar. The best part? That's not some crazy high dose you can only get in a lab. It's a concentration your body can easily reach after a normal meal that contains choline. This is really happening inside our bodies.
Okay, so we've got a theory. A molecule, TMA, has a target, IRAK4. But in science, a theory is just a theory until you prove it in a living system. So let's move on to the evidence and see how the researchers built their case, piece by piece.
First up, the diet experiment. They put mice on a high-fat diet. You can see in that first bar, the group with low choline got metabolically sick. They developed high blood glucose. But now check out the second bar. When they gave mice the exact same high-fat diet but added extra choline, the mice were completely protected. Their blood sugar stayed perfectly normal, just like the healthy control mice. That's huge.
That's a fantastic result, but it brings up a really important question, right? How do we know for sure it's the bacterial TMA doing the heavy lifting and not just the choline itself having some other effect? How do you possibly separate those two things?
Well, this is where the science gets really elegant. They tried two things. First, they gave the protected mice antibiotics to wipe out their gut bacteria, and poof, the benefit vanished. Then, they used a special chemical that doesn't kill the bacteria, but it does block the specific enzyme they use to make TMA. And again, the benefit completely disappeared. That is proof positive. The hero of this story is the TMA made by the bacteria.
But the scientists wanted one more piece of evidence. The final, undeniable, slam-dunked proof to connect TMA directly to its target, IRAK4. And for that, they turned to genetics.
This chart right here, this is the genetic smoking gun. They use special mice that were engineered to be born without the IRAK4 gene. They're called knockout mice. When they fed these mice a high-fat diet, they were basically immune to the bad effects. Look at that second bar. They maintained excellent glucose control, perfectly mimicking the mice that were getting TMA. Case closed. TMA protects us by shutting down IRAK4.
So what does this all mean for us, for the future of medicine? In our final part, let's zoom out and look at the incredible new frontier this discovery is opening up.
This research is giving us a whole new concept, a whole new way of thinking. Microbiome kinome crosstalk. What it means is that our gut bacteria are not just sitting there digesting food for us. They are an active, living pharmacy inside of us, producing powerful chemical signals that talk directly to our cells' operating systems to regulate our health in real time.
So let's put it all together and resolve this paradox once and for all. The bacterial gas, TMA, is good, especially when you're eating a bad diet. It targets IRAK4 and blocks inflammation. It's the liver's exhaust, TMAO, that's processed differently and is the molecule associated with cardiovascular risk. They are two different molecules with two very different jobs. Context is everything.
And this really forces us to move beyond this simple idea of having good bacteria versus bad bacteria. The future of gut health isn't about who is living in your gut, it's about what chemicals they are producing. It's not about identity, it's about function.
And that leaves us with this one incredible final thought to chew on. If our microbes are making a natural drug-like anti-inflammatory compound from something as simple as choline in our diet, what other secret medicines are they cooking up for us right now, just waiting to be discovered?